Hello everyone. So today's topic is pair of straight lines. Another interesting topic in two-dimensional geometry. As we are discussing about the two-dimensional geometry and we have started our journey through transformation of rectangular Cartesian system. So in pair of straight lines, we are talking about two straight lines always. So what is that? Suppose you have two straight lines and you know that what is the standard form of the straight lines. So considering two straight lines, equation 1, a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. And let us take the combined form of the lines. So you can write combined form in equation 3. So the advantage is that the coordinates of any point on 1 satisfy the equation 3. And hence all points of the straight line 1 lie on 3. Okay, so any point on 1 will satisfy naturally equation 3, and similar statement can be made for equation 2 also. Similarly, all points of the straight line 2 lie also on 3. Hence the equation 3 represents both the straight lines, right? 1 and 2. Now if you expand 3, we get our second degree equation in x and y. And we say that equation 3 represents a pair of straight lines 1 and 2. So if you expand, let me expand this equation. So if you expand, you have a1. Okay, let me write in a different platform. Okay. So your first equation is a1x plus b1y plus c1 times a2x plus b2y plus c2 equal to 0, right? So if you multiply, it will be a1, a2. If you expand throughout, x squared plus, if you take a1, b2 plus b1, a2, xy, x times y, and if you take b1, b2, y squared plus a1, c2 plus c1, a2 times x, right? Plus b2, c1 plus b1, c2 times y. And lastly, you have c1, c2, the constant term equal to 0. So look at that. You got a second degree general equation of second degree. What is your general equation of second degree? The general equation of second degree can be written as ax squared twice hxy plus by squared plus 2gx plus 2fy plus c equal to 0. So this is your general equation of second degree, right? So you gotta, if you expand this, you have a form like that. So you look at that, the previous expansion of the two lines are of the form this. You have a squared, x squared, you have y squared, you have xy term and the coefficient, you have x term, y and the constant term. So you have this. So it's similar to your general equation of second degree. That means if you multiply two lines, you will get a general equation of second degree. So this general equation of second degree represents a pair of straight lines. Okay. So that is our first lesson in this lecture. Now let us move forward. Let us state a theorem, a very interesting theorem. A homogeneous second degree equation always represents a pair of straight lines passing through the origin. So what do you mean by homogeneous equation? So what do you mean by, firstly you have to know what do you mean by homogeneous function. Suppose I am giving you one example of a function. fxy equal to ax squared twice hxy plus by squared. This is a function of x and y. You look at that, it is a type of homogeneous functions. Why? This is, suppose you can write this equation in the form, if you can take x squared common, right? So you can write a plus 2hy by x plus by by x y over x squared and whole. So you have a form of x squared function of y by x. So if you write any function in this form, x squared function of y by x, that is a homogeneous function of degree 2 because of this power 2. Or this equation can be written as y squared f of x by y, also taking y squared common, right? In this way you can write both the functions as homogeneous. You can show, or you can check it by inspection. How? Because x has a power 2, xy combined power is 2, and y squared is 2. Another way you can define it, suppose t is a number greater than 0, you can write f of, you can show it, f of tx comma ty is t squared f of xy. So it is a homogeneous function of degree 2. In 3 ways you can express it as a homogeneous function of degree 2. In that way you can express homogeneous function of degree n. That is the way of expressing homogeneous functions. So homogeneous second degree equation always represents a pair of straight line passing through the origin. So let me give you a diagram for that first. So this is L1. L1 is represented by y equal to m1x. Suppose it is a straight line passing through origin and its slope is given by m1. And this is the second line, it is given by y equal to m2x. It is a second equation passing through the origin, and you know that any line passing through the origin can be represented as y is equal to mx. So y equal to m1x and y equal to m2x are two lines, and they are combined, that is the pair of straight line will represent a homogeneous equation. So we'll prove that. So if you write y minus m1x into y minus m2x, so if you expand and you can check that it is written as y squared minus m1 plus m2 into xy plus m1 into x squared, right? m1 into x squared. So that is a homogeneous, it is a homogeneous equation, homogeneous second degree equation, because already I explained this is in this form. So this represents a homogeneous second degree equation, and y minus m1x, y minus m2x is the combined form of the pair of straight lines. It represents the pair of straight lines. So that was the theorem. The theorem was talking about a homogeneous second degree equation always represents a pair of straight lines passing through the origin. Okay. Now you can write this equation. This is a homogeneous equation, quadratic equation in x and y. So this can be written as, if you take b, then this can be written as like this, and you can comparing these two lines, you can comparing this and these two lines, you can check that m1 plus m2 equal to minus twice h by b, and m1 m2 is a by b. Okay, m1 plus m2 is minus 2h by b, and product of m1 m2 is a by b. So some of the roots you can say it's this, and the product is a by b. So this is the important relations about homogeneous second degree equation or pair of straight lines. So homogeneous second degree equation represents two straight lines, y equal to m1x and y equal to m2x passing through the origin. That was our target. So finally the conclusion is that a homogeneous second degree equation always represents a pair of straight lines passing through the origin. Okay, and this is the diagram for them. Next, let me find out the next step. Let me find out the angle between the pair of straight lines passing through the origin. What is the angle between the pair of straight lines passing through the origin? So the angle is given by tan theta, and you know that angle between two lines, suppose this is the angle theta, this is the angle theta between two lines L1 and L2, and you know that this results from very elementary level that tan theta is modulus of m1 minus m2 by 1 plus m1 m2. Now you know you can express m1 minus m2 as squared root of m1 plus m2 whole squared minus 4 m1 m2, and you know the values of m1 m2. M1 plus m2 is minus 2h by b, and m1 m2 is a by b. If you substitute, you will get a relationship. This is actually theta. This is actually theta tan inverse twice square root h square minus ab by a plus b over a plus b. So this is the angle theta between two straight lines. Very important relations in pair of straight lines, and very easy to evaluate. So some notes on that. If two straight lines be coincident, then theta equal to 0. So you have a relation h square equal to ab. So what is the condition that the two straight lines are coincident? They will represent the same line. The condition is h squared equal to ab. That is the condition, because tan theta is 0, tan 0 is 0. So h square equal to ab. You will get this from this relation. And if two lines are right angle, that is tan theta is 90, tan 90 is undefined. Hence, your denominator must be 0. That is a plus b 0. And a is the coefficient of x squared and b is the coefficient of y squared. So, sum of the coefficient of x squared plus coefficient of y squared will be 0. That is the condition. You can check this condition in problems that two lines are perpendicular. Okay. Next, I shall be talking about the bisectors of the angles between two pair of straight lines. So, if this L1, L2 are the pair of straight lines, then there are two bisectors. You see, one of the bisector is acute angle bisectors, that is called A1. Another is obtuse angle bisectors, that is called A2. So, there are two bisectors. Now, how will you get the bisectors? How will you get the equations of the bisectors? Let me show you in this case. So, okay. So, again, let me draw the diagram for that so that you can understand. So, these are the two lines. So, lines are represented by, this is one of the line L1 and this is another line, suppose L2, straight lines, and two bisectors are, this is the acute angle bisectors, right? And this is your obtuse angle bisectors, okay? So you want to find out the equation of these two blue lines, the bisectors A1 and A2. Now how will you get the bisectors? And this line is y equal to m1x. Already explained about that. And this is your y equal to m2x, right? So you have an idea about that, how to get. And this is the bisectors A1, A2. So you know that from elementary level, the equation of the bisectors can be written as y minus m1x by squared root of 1 plus m1 squared equal to modulus of 1 minus y minus m2x by root of squared root of 1 plus m2 square, right? This is from elementary level. You know that that is how you have to write the equation of the bisector, and that will give you the bisectors. So if you open the modulus, there will be a plus minus sign, or you can take a square on both sides, squaring and cross multiplying, right? So if you take the square, y minus m1 square plus y1 plus m2 square, it is a cross multiplication, and y minus m2 x whole squared into 1 plus m1 squared, right? So if you multiply and if you simplify, you can use those relations. Okay, you can check those relations. What is the relation? The relations are m1 plus m2 is minus twice h over b, and m1 m2 is product of m1 m2 is a by b. That is the relation between m1 m2, their sum and their product. So after the expansion, I'm just giving you a hint to how to find out the bisectors. So if you expand throughout, you will and you have to use these two relations, you will get the bisectors in this form. So that is you can try this one, x square minus y square by a minus b equal to xy over h. So this is the equation of the bisectors. This is very important relation. And you look at that, one more thing, This also represents the pair of straight line. If you cross multiply, it will be hx squared minus hy squared minus of a minus b xy, because these bisectors also passing through the origin, so they will represent the homogeneous second degree equation. These bisectors are also passing through the origin, so they will again represent a homogeneous second degree equation in x and y. So this will represent a pair of straight line passing through the origin also. So this will be the bisectors. So that was the proving. So I'm just giving you the hint so that you can find out the bisectors in that way. Just the simple calculations you need. Next, just come to the last point. There is a proof, product of the perpendiculars from the points x1, y1 on the straight lines represented by this is this. You have to prove this, right? You have to prove that product of perpendiculars from the points this on the straight line this is this given by this. So I will show you the hint also how to prove this one also. Okay, so let me add a page here. Okay, so your diagram will be like this. This is your lines, this is your straight lines passing through the origin L1 and L2. Now product of the perpendiculars from the points, this is your P point. Suppose this P point is x1, y1, right? Anywhere in a 2 dimension. So this is your product of the perpendicular. Suppose P1, this is the perpendicular, and this is P2, perpendicular from P to L2. So your product of the perpendiculars is P1, P2. And okay, what is your P1? This line is y equal to m1x. So your first product is y1 minus m1 x1 by root over 1 plus m1 square. That is the perpendicular formula, right? You are applying that formula. And modulus of y2 minus, actually no, sorry, not y2, it is y1, because your point is x1, y1. That is the elementary formula you are applying. m2 x1 by root over 1 plus m2 square, right? Now if you take the product, then that will be y1 squared minus m1 plus m2 into xy, okay, and plus m1 m2 x1 squared, right? And the denominator you can write 1 plus a square root. You can multiply throughout 1. If you multiply and expand, you will get m1 squared, m2 squared plus m1 squared plus m2 squared. That will, and if you simplify, you can simplify, you can write the formulas for a square plus b square, and if you simplify you will get the result. What is the result? The result is here in the theorem. This will be the result. So that is the problem where you can find out the product of perpendiculars from the straight line this, rather from the points x1, y1 on the straight line this. So that is how you can solve so many problems in pair of straight lines using these beautiful results. So these are the important results. You can use these results and theorems in your solving pair of straight lines problems. Also, in case of let me stop with a discussion. If your pair of straight lines are not passing through the origin, then in that case your pair of straight lines will be this type. Suppose this is the pair of straight line, they are not passing through the origin. Suppose this is your first line L1x plus m1y plus n1 equal to 0. This is the first line, and L2x plus m2y plus n2 equal to 0. This is the second line. So these two lines combined, what is the combined form? Actually, already I have explained the combined form in the first slide. Initially, when I was talking about the, yeah, this is the form. This is the form. You look at that. This is the form. So this is your a1, a2. This is the coefficient of xy. This is the coefficient of y square. This is your coefficient of x. This is the coefficient of y, and this is your constant term. So you can compare these results with the general equation of second degree, this one, and you will get beautiful results. You can solve. So lastly, I was explaining about the if the straight lines are not passing through the origin, then how will you solve the problems? The problems can be solved by this, using these results, combined form, using comparing with the general equation of second degree, and whatever questions is asked in the paper, accordingly you will solve the questions. Okay, so that is how. Okay, I think this lecture is helpful for you everyone. Thank you all of you.